So if you want to answer that question, I'll be back in a second. Okay, glass is transparent, so it can be seen through. It's hard, so it stays in place in the window frames, and it's heat resistant. Okay, so if you ever touched a window, it's not melting from the temperatures that we normally have. It has to get a lot hotter to melt. So, but it also keeps the heat outside and the cool inside. So it's an insulator. Okay, what kind of properties would you use to determine what kind of substance you have without knowing the amount of substances? You can't measure mass or volume. So if you can't measure mass or volume, you probably can't measure density. But what other things could you measure? Okay, or what class of things could you measure? All right. So we would basically measure the intensive properties. All right, because the intensive properties are those that don't change regardless of the amount of substance that we have. Now, this is my favorite part here. What are the 3 states of matter? Actually, there's 4 states of matter. Now, on Earth, we don't see the 4th state too often. We usually see that in places like the sun. But if you're really good and you remember what I say right now and ask me in class, I'll show you the famous solid, liquid, gas, plasma dance. Remember, you have to ask if you want to see it. All right. So the 3 states of matter are solid, liquid, gas, and the 4th state is plasma. Okay, I like to make sure we don't forget plasma. All right? So you're very familiar, I'm sure, with water. I hope you are. Now, water, we often see it as ice from the freezer. And sometimes if we're cooking, we see the steam coming off of the pot. So we've seen all 3 forms of water. We, in fact, give them separate names: ice, water, and steam. But they're all water. It's not just the liquid phase. They're all water. Solid water is ice. Gaseous water is steam. Okay? So we're familiar with that. Every substance has those 3 states. Now, we don't always see all 3 based on some characteristics, but they do all have those 3 states. All right. Once again, solid, liquid, gas. I'm going to write it down. The 4th state is, remember? I hope so, plasma. Kind of sounds like a horror movie. Plasma, okay, is found in the sun. And all plasma is, if you want to remember what plasma is, it's kind of like a really, 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 really hot gas. It's so hot, the outer electrons have been stripped off of the gas so that it's positively charged, and it's a superheated, excited gas that lost some of its electrons. Okay? So it's gas that lost part of itself. Now, where have we seen on Earth? Well, if you've heard of plasma television, which is kind of old school now, that's one of the places you might see on Earth. There's also a couple scientific instruments that use plasma, but you need a lot of energy because you got to strip off those electrons, and it's not that easy to do that. All right, let's talk about each form of matter. Okay, a solid form of matter has 2 things that you must know. Okay? It has a definite shape and a definite volume. So if I gave you a rock, you would definitely look at that rock and say, oh, that's kind of a unique looking shape. And we could put it in a large graduated cylinder and find its volume. Okay? Both of those things are definite. All right? The shape does not depend on its container. It has its own unique shape. If you have an ice cube, put it in a glass, it still has that shape and still it starts melting. Because what does it become? It becomes a liquid then. Okay? So if we look at these pictures, we can see an iceberg. Okay? And if we look down the microscopic, submicroscopic level, we see that all the little atoms or molecules of water all have a specific shape, and they're tightly packed together. There's not a lot of space in between each of the molecules. So it's very ordered and very structured. Okay? So what we can say about a solid is that it's very ordered, and very structured. Okay, so that's our solid. Now, if you have something that's not got a lot of space between it, and you try to squeeze it, what's going to happen? Not much. So we say that that is a property of a solid called incompressibility. So solids tend to be incompressible. If you put enough force, they're going to shatter. What if we heat it? Usually when things are heat, they expand. A solid won't expand very much. It will expand a little bit, but it won't be noticeable to the human eye. Now liquids. Liquids are a little different. Liquids are a little bit more flowy. They can move around. They take the shape of their container. They're not like confined to their own shape. They take the shape of whatever. They're kind of shape shifters, all right? They're still touching each other, still close in contact, but it's not as like ordered. They're kind of like, you know, they're not orderlies like the solids are. They like to be free-flowing. Ha. All right, that was a little chemist joke there. All right, so we have the water. If we look at the submicroscopic level, we see the individual molecules, and we see lots of space in between them, but they're kind of still touching each other. Okay? So they're free to flow. So what can we say about liquids? We can say they take the shape of the container. Okay? But the volume doesn't change. Okay? So they have a constant volume, but they take the shape of the container. So they don't have a definite shape. So solids have a definite shape and a definite volume. Liquids have a definite volume, but not a definite shape. Okay? So if we look at this definition, we see that it has an indefinite shape and it has a fixed volume. And a key word for liquids is that liquids flow. Okay? Now, you might have heard of hydraulic lifts if you ever gone to a auto shop that lifts up the car. So what happens is we put pressure on the liquid and it kind of resists that. It'll move a little bit, but it's nearly as incompressible as a solid. But that pressure then makes the lift go up. Now, what's different is a liquid, you will see some expansion when it's heated. Okay? If you have a container and can monitor the volume, you will see it expand slightly. Not that much, but it will expand more than a solid will. Now we get to the gases. Okay? So the gases, they're really free spirits. Okay? They're like the liquid, and they take the shape of the container they find themselves in. Like, look around the room. Is it empty? Can you see any substances? No, you can't see them, but you know it's there. Why do you know? Because you're still breathing. So we know there's at least one thing in this room. What is that you can't see? Oxygen. Oxygen is a gas. So what is the shape of the oxygen? It's the shape of this room. So it takes the shape of the container. But what if we open the door? Then some of the oxygen can go out in the hallway. So it can expand to fill any volume. So gases have an indefinite shape and an indefinite volume. So it has no definite volume, no definite shape. So it will take both the shape and volume of the container. So if we look at the little submicroscopic view, we see lots and lots of space in between each of the particles of the gas. Okay, so they're farther apart. Now you take some pressure. There's all that empty space, so we can compress a gas into a smaller volume. So gases are compressible, and that's an important characteristic for gases. Now, sometimes we use the word vapor and we use the word gas. And we use it interchangeably, but there's a subtle difference. Gas is usually used for substances that exist as a gas at room temperature. Okay? So oxygen, nitrogen, they're normal gases that you can't see but are around us. And we know they're around us because A, I told you can breathe. B, if it was pure oxygen, we'd all be on fire. So that would be a good thing. So the nitrogen is inert and takes up almost 80% of the atmosphere. And that nitrogen keeps the oxygen from burning spontaneously. Okay? Vapor is a gaseous state of a substance that is usually a liquid or solid at room temperature, but has been heated. For instance, water vapor. There's going to be some vapor escaping. That's why you see dew in the morning some days, because what is a cloud? Cloud is water vapor. And condensation, as it cools down, there's lots of water that has formed into gaseous phase because of the heat of the day, and then when it condenses back down, we see it back into liquid. So it's normally at room temperature, it's a liquid, but some of it gets excited and becomes its gas even at room temperature, okay, because of the heat around it. Okay, question time. A substance is in a state in which it takes the shape of its container. What state or states could it be in? It's going to be on a question for you. Be back around after the question. Did you get it right? Definitely not a solid, but it could be a liquid or gas. They both take the shape of the container. Now, we've talked about physical changes. Now, how do we classify physical changes? Let's look at some things. All right, if I take gallium, gallium is a metal, but at about 30 degrees C, it will start melting. So sometimes in the summertime, it'll get to be about 35 degrees here. So if you had a piece of gallium, it would turn into liquid. Also, if we look at the picture, we see somebody have it in their hands, and as I said previously, body temperature is 37.5 degrees Celsius, so it melts. So it's not like an M&M, which doesn't melt in your hands. It melts in your hands. Okay, but if then we pour it into a container and the room is 68 degrees, it will turn into solid gallium again. So what happens to this shape? If that was a square block of gallium, okay? So if we had we're at 20 degrees Celsius. All right. And we have a nice block of gallium. Okay? And then you say, oh, that's a nice block of gallium. I'm going to pick it up. So now it goes to 37.5. Now you have a mess. You have a big blob of gallium, liquid gallium. Okay? Then you say, oh man, I'm going to get rid of this. So you put it back in a beaker. And so here goes and you make, this is solid again as it cools down. Okay? But in all three cases, you've got a nice block, you got kind of a blob, and then you've got a solid that's formed in the bottom of this beaker that doesn't look like the square because it was liquid and it's solidified in this shape. Okay? But it's in this shape now. So melting or freezing is a physical change. In all three cases, it's the same gallium. It just looks different. So these words, boil, freeze, melt, and condense, are used to describe physical changes. These are things that are reversible. Break, split, grind, cut, crush. Okay? These words usually mean if you break a piece of glass, it's hard to put it back together again. Kind of like Humpty Dumpty. All right? If you grind something up into little particles, try putting it back together. Okay? If you cut a loaf of bread, you can't really paste it back together. You could, but it'd probably be really tasteless. All right? So these words would be irreversible. So some physical properties are reversible and some are not. So melting and boiling are reversible. So with the gallium, okay, it can go back and forth between liquid and solid. Now that's not saying that when it forms a solid again, its shape may be different than the initial solid, but it's still a hunk of gallium. Now, anytime you go from one state of matter, meaning solid, liquid, gas, to another, it's reversible. Now, some things that would be irreversible if you got your hair cut. I guess you could go down to the floor of the barbershop and paste it back in your head, but it's just not the same thing. We know some people do that, but I don't think it's very attractive. Filing nails, you're not going to get those little pieces of your nails back and get long nails again, sorry. Or if you crack an egg. Humpty Dumpty sat on a wall. You got it. You know what happened to him. Water boils and becomes water vapor. Is this reversible or irreversible? Think about that for a second. I'll give it to you as a question. Back around. It's reversible. It's a phase change. It's going from solid, liquid to gas. So what you would do is you'd put the gas through something cool and you got liquid again. All right, to summarize. Every sample of a given substance has identical intensive properties because every sample has the same composition. 3 states of matter, solid, liquid, and gas, but don't forget good old plasma, the 4th state. Physical changes are classified as reversible or irreversible. Reversible, you get it back. Irreversible, once you do it, sorry. Okay, here's your definitions that you should have in your notebook. Stop the tape. Write them out in your notebook in OneNote. Know them. Okay, here's some more. Stop the tape. Write them out. Once again. All right, one of the things we're going to talk about, we always call chemistry the central science. Okay, one part of the central science is physical properties. And we use them to describe matter. A lot of times they're intensive properties. So boiling point, melting point are things that are used. That's it for this section. See you in class.